Hello to anyone and everyone watching. I'm making a little video on the schematics of my F motor that I built. This is my first prototype, second rocket motor ever. Basically, here's everything that it has. Most of this is taken from Richard Naka's website. He has a whole bunch of awesome formulas on how to determine what size you want to make your grains and what size to make your nozzle and motor and everything. But basically I decided that I wanted to ensure 1000 psi maximum as KNSB, or the grain that I'm using, potassium nitrate sorbitol, burns optimally at 1000 psi. So I basically the reason I made it this size was just because it was the only tools that I had were to make a 5/32 inch nozzle, and so I couldn't make anything. I basically started the calculations with the nozzle size and worked backwards to get the grain size. So there's 4 grains, each of which being 1.25 inches long. There's an outer diameter of 0.75 inches and an inner diameter of 0.25 inches. It's a base grain, so it has spacers between each one of them. The spacers that I used are washers. The nozzle is made with Durham's rock hard putty, and it has smaller washers inside of it in order to make sure that the nozzle doesn't erode, because the putty is not really strong enough to withstand the pressure and heat. I also use Durham for the 4 enclosure, and I use some JB Weld, which I understand has a very high heat capacity or heat sustainability, in order to not melt very fast. So I use that JB Weld epoxy, and I also made a fillet in the back there. The reason why it goes grain 2, 3, 4, 6 is because it's actually in the order of the grains that I made. So the first grain was a test throwout grain, and I messed up with grain 5 because I just wasn't patient enough, and I took it out too early and destroyed the grain. So I had to make a new grain for that one, which kind of sucked. So all in all, our mass of our entire rocket motor is 186 grams. Propellant mass is 61.2 grams. Casing mass is 124.8 grams. I believe that we are going to be able to get a specific impulse of 110 seconds, although it could be lower, it could be higher, no idea, but that means my expected total impulse is going to be 66 Newton seconds, which puts it at a medium-sized F motor, a little bit on the lower end of the spectrum. Well, yeah, the medium-sized. The igniter system, let me grab the igniter real quick. It's I used a modified Estes black powder igniter, so one of the really old ones that they don't make anymore. Honestly, if this entire test doesn't work, it's probably going to be because this igniter doesn't work. I'm not very good with pyrogenics and electronics. I don't know much about voltage and amperage and everything, so I'm really crossing my fingers that this works, and I only have a very limited amount of igniters, so I'm trying to limit the amount that I'm testing them so that I don't keep on using these igniters. So I hope that I built it the right way, and if I didn't, then I have some nichrome wire coming in, and I'll make one the next day. So let's see what the motor looks like. I keep it in this box with a desiccant packet so that it doesn't absorb the moisture in the air. It's a little bit less than 38 millimeters on the outside, which is why I put this tape around it, because the casing that I use is 38 millimeters. You could see this is the aft enclosure, so that part of the rocket, it's right there. And you've got that was a 4 enclosure, sorry. And here's the nozzle. Lighting's not great, so you can't really see the washers, but that's that part of the rocket right there. And well, yeah, that's basically all I have to say about it. I think some of the grains are a little bit overcooked. In a couple of cases, it seemed like they caramelized a little bit. So for my 5th and 6th grain, I actually worked on lowering the temperature of the cook, but I don't know if 3 and 4 are going to be as optimally burning because they're a little bit caramelized, but I decided to use them anyways. Might as well. I made the grain. So yeah, let's go out to the field and test it. Alright, so we brought it out to the park. Here we are. We've got the electronics set up and the igniter right here, and right now we are calibrating the load cell. Here's the motor all ready to go, and I'm going to record it with a GoPro up close. Alright, we're ready. Okay, 3, 2, 1. So yeah, that's what a failure looks like. At least it didn't KO, but it turns out I was right about the igniter not working. It did light, but it just didn't burn hot enough in order to ignite the motor. Last night the 36 gauge wire came in, and I took to creating this this igniter right here. I've tested it on some grain, and it should work. I don't think it's gonna. There we go. And so basically I just ground up some sparkler powder and some match head powder, and I made it really fine and glued it onto the end of the nichrome wire that's attached to the end of the double wire. One other thing that we were thinking about was safety, and we sort of determined that our setup was pretty dangerous. Just standing far away from it isn't really the best way to do things. So we've decided that instead of going to the park, we are going to make a setup here at my house and light it in the lanai while we stand inside, and I'll show you what that setup looks like right now. So here's that setup that I was talking about. We've got 8 cinder blocks stacked one on top of the other with a concrete roof. We got a little hole for the exhaust right here, and the motor goes right there. We're gonna have the GoPro right on the outside right about there so that we could look at the exhaust and hear what the motor's doing. And yeah, that's about it for that. There's very few holes in it, so if we do get a KO, it probably won't blow up our lanai there. Okay, that camera's on. Yeah. Okay, stop looking. 30 seconds on my mark. 3, 2, 1, mark. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition.
Okay, we got 30 seconds.
Kato. So yeah, that was a slightly more serious failure than the last one. We had a KO on the launch pad, lost the motor about half a second into the flight. I spent about 4 days trying to figure out what happened and piece everything together, when it happened, why it happened, how it happened, everything. So here's the data that I was able to collect from it. When I initially walked up to the motor, I saw that the nozzle was completely gone. It had just burst out, and there are 2 different possibilities for this. The first one was that the cement that I used had completely eroded away, but it seemed much more likely that it actually just completely popped out of the casing because I hadn't sealed it in well enough, which we were able to kind of prove the next day when we found in the pool there is this intact piece of nozzle cement, and you could see that right at the top there, that's where the washer would have fit for the nozzle, which is the washers that are right about there. And so it was proven that the way I glued the nozzle in wasn't good enough. So after I found out what the failure was caused by, I took to finding out what pressure the nozzle burst at. And using this formula right here, I was able to find that it burst at about 11.8 atmospheres, or somewhere around 180 psi, something like that, which is pretty low compared to the 1200 that I expected. Anyways, here's the data that we got from the dynamo. It basically shows the rocket going up to pressure and then bursting at that 11.8 atmospheres, or about half a second in. Able to put together these 3 frame-by-frame videos of what happened. They don't really reveal too much about it, but I just found it kind of cool that I could get them all at the exact same time. That's basically all the data that I got. I wasn't able to find the specific impulse because we didn't get a full burn. I wasn't able to figure out the maximum chamber pressure, the KN, or anything, just because we didn't get to that max before the nozzle burst. So it's a little disappointing, but we still got some pretty neat data out of it. Anyways, thanks for watching if you made it this far through my boring old video. Hopefully my next motor that I make will be a little bit less chaotic and show a little bit more data. See you next time.